Welcome to physics classes for IIT JEE and Neet exam. Today's topic is dimension formula from units and measurements chapter, which is very important. Every year there are questions appearing in IIT JEE mains as well as advanced and also in Neet exam. So this topic is very important. First of all, look at this question. This question came in 2022 JEE mains. So here the question reads like dimension of mutual inductance is. So the options are 4 are there. So to answer this question we need to know the formula of mutual inductance and their dimension formula also. Look at this question. The SI unit of physical quantity is Pascal second. The dimension formula of this quantity will be. So to answer this kind of questions, we need to know the topic of dimensional formula and dimensional analysis. I am going with an example. What is the distance between Hyderabad and Delhi? It is around 1500. What is that 1500? Is that a meter or centimeter or millimeter or kilometer? So the 1500 is the kilometers. The distance between Hyderabad and Delhi is 1500 kilometers. Here the 1500 is a number and kilometer is a unit. I can convert this kilometer into meters, centimeters, even into millimeters also. Means this distance I can show in different forms. Means the units of the distance or units of the length are different. For example, centimeter, millimeter, kilometer. But these all are the forms of length only, right? So the length has a dimension formula of capital L, which should be enclosed in a square closed brackets. So what is dimension and what is dimension formula? Means the physical quantities can have multiple or different units. As I told you that the length has meter, centimeter, kilometer. For example, the mass has kg, grams, etc. So there might be multiple and different units for a physical quantity, but with same dimension formula. You take kilogram or you take grams. For those two things, it is the measurement of mass only. That's why its dimension formula is capital M only. There is no separate dimension formula for grams. There is no separate dimension formula for kilograms. So grams, kilograms is nothing but mass only. That's why its dimension formula is capital M. So let me go with an example. So we know velocity, its unit is meter per second, or we can write in centimeter per second, or we can write in kilometer per hour also. So these all are the units of velocity, but it is in the form of length upon time, L by T. You can write that L by T in the form of L T power minus 1 in a closed square brackets. This L T power minus 1 in the closed square brackets is the dimension formula of velocity. So we know that velocity is nothing but length by time. So that is meter per second or kilometer per hour. But its dimension formula is length by time. Let me go with another example. Acceleration. Its units are meter per second square or kilometer per hour square or centimeter per minute square. These are the units. These are in the form of velocity by time. So velocity dimension formula is L T power minus 1. So divided by time is there extra in this acceleration. So if we bring this denominator T to the numerator, again it will become L T power minus 2. So this is the dimension formula of acceleration, L T to the power of minus 2 in the closed square brackets. So this is the way we need to write the dimension formula. Units might be different, but dimensional formula is same. In physics, the dimension formula is an expression that shows how and which of the fundamental physical quantities are required to represent a physical quantity. It means, for example, we have velocity as meter per second or kilometer per hour. So there are two multiple units are there. To denote these physical quantity, So how and which of the fundamental quantity we need to use? We have fundamental quantities around 7. So mass, length, time, electric current, thermodynamic temperature, luminous intensity, and amount of substance, etc. So these are the fundamental quantities. So out of these fundamental quantities, which we need to indicate to that velocity. So for example, meter by second is there. Meter is in the form of length. Second is in the form of time. So length by time. Length is a fundamental quantity. Time is a fundamental quantity. So we need to indicate these fundamental quantities in a closed square bracket, that is nothing but our dimension formula. So it should be indicated or denoted with the symbols of fundamental quantities in a closed square brackets. So these are the fundamental quantities with their dimension formula. So length is capital L, mass is capital M, time is capital T, temperature capital K or theta, electric current capital I, amount of substance capital N, luminous intensity capital J. So based on these 7, there are hundreds of physical quantities are formed in a physics. Around 100, 150, 200 equations are there in physics. So we can write dimension formula for every formula in the physics. So that's why every formula in our physics is important to get in the examination of IIT, JEE or Neet. So that's why learn all these dimensional formulas and apply these fundamental quantities dimension formula knowledge into the real equations. So what is dimensional analysis? Do you know it is a method used in physics to convert units from one system to another or establishing relations between physical quantities. So this dimension analysis relies mainly on the physical or fundamental quantities, mainly length, mass and time. Most of the physical quantities are formed by length, mass, time. So what are the applications of dimensional analysis? Means to check the equation consistency and to convert the units and to verify the derived equations. These are the applications of dimensional analysis. The first application is checking equation consistency. That is nothing but dimensional homogeneity. What is this dimensional homogeneity means? If an equation is there, that equation might consist of number of physical quantities. According to this principle, homogeneity principle, every physical quantity has to come with same dimension formula. Then only it is called as dimensional homogeneity. Let me go with an example. If you see this S equals to ut plus half at square. We have equations of motions. This is second equation of motion. S equals to ut plus half at square. We know v equals to u plus at. We know v square minus u square equals to 2as. So out of those three equations of motion, I have taken this second one, S equals to ut plus half at square. If you consider S as separate quantity, ut as separate quantity, at square also separate quantity. Anyway, 1 by 2 is a constant number. There is no dimension formula for the numbers. So that's why S is a separate quantity, ut is a separate quantity, at square is a separate quantity. For these three separate quantities, what is the dimension formula? If you see, S is nothing but distance, u is nothing but initial velocity, a is nothing but acceleration and t is nothing but time, right? So we know that S is nothing but distance. It is measured in the form of length. So that's why its dimension formula is capital L in a square closed brackets. So if you see ut is nothing but, u is nothing but velocity, velocity is nothing but L by t into another t is there ut, so multiply t, then you see that, so numerator t and denominator t gets cancelled, so we are remaining with the capital L. Did you understand? S came with L dimension formula and ut also came with capital L dimension formula. Let's see this half at square. So we are not considering 1 by 2, it is a constant number. So at square, if you consider a is an acceleration. Acceleration we already know, L t power minus 2 and t square is there. So t power minus 2, t power plus 2, both are gets cancelled. We are remaining with capital L. Means in this S equals to ut plus half at square formula, S came with capital L dimension formula. Even ut also came with capital L dimension formula. Even at square also came with capital L dimension formula. So all these three came with same dimension formula, that is capital L. Hence this equation is dimensionally homogeneous. It's very important. If any equation has multiple quantities, check them whether they have same dimensional formula or different. If it is having same dimension formula, it is called as dimensionally homogeneous. The next application is verifying derived equations. Let me go with an example. We have f equals to ma. So f equals to m times a. So we need to verify that this derived equation is consistent or not. Let's see that f equals to w. Can we write force and weight equal? Yes. W is nothing but weight. It is equals to mass into acceleration due to gravity. So m into small g. M is nothing but mass. Mass का dimension formula capital M, and g is acceleration due to gravity. So acceleration का dimension formula is L t to the power of minus 2. Hence f equals to, or the dimension formula of f is m L t to the power of minus 2. If I go to the right hand side, m is mass. For mass, capital M is the dimension formula. If you go for a, that is acceleration. Acceleration का dimension formula is L t power minus 2. Hence f का dimension formula is m L t to power minus 2. Even ma का dimension formula is m L t to the power of minus 2. Means f equals to ma is verified as a correct equation. Why? Because left hand side and right hand side both the dimension formulas are same. Hence the dimensions of f is equals to dimensions of ma, that is equals to m L t power minus 2. This is the dimension formula for this force. Like this, we need to write the dimension formulas for every equation. We can also convert units. For example, we can convert meters into centimeters, centimeters into millimeters. That is also done by this dimension formula. So these are the different applications of dimensional analysis and dimension formula. So this is very important. Try to learn all the dimension formulas for every quantity in the physics. We can determine the dimensions of unknown quantities also. For example, density is there. It is nothing but mass upon volume. So we know that mass is nothing but capital M. So volume is nothing but L cube. So m by L cube, we can write that as m L power minus 3 as the dimension formula of density. If you see kinetic energy, half into mass into velocity square, half mv square, half is a number. So mass is capital M, velocity is L by t square. So like this we can write all the dimension formulas. All the best for your NEET exam, IIT JEE exam. Share this video, do like and share